So welcome to my presentation about web-based remote user interfaces for MIDI devices, but basically any embedded devices. What I will talk about is focused on hardware devices. So it's a bit of a cuckoo's egg here because it's not related to software plugins or maybe not even related to JUCE. But I think those people who work with JUCE, and we do also use JUCE, may be interested in these ideas. So the problem is very often with hardware devices that the cost is a limiting factor. So it has to be cheap. It's not like software where you write it once and you can sell it as many copies as you can. But hardware is, you have to pay for it. So therefore, usually it is very, the cost is very limited. So the idea was that instead of having a UI, a user interface, on the device itself, why not implement it on a separate device which has much more resources, a high resolution display. So the basic idea is that we would share the tasks of the audio processing being done on the device and the user interface being done on some kind of computer, which can be a desktop, a laptop computer, or a tablet. So my vision is to create an open standard for building a graphical user interface for small resource-constrained devices. I think this is a standard much like MIDI, but for the UI, the UI of MIDI instruments would be very helpful for many manufacturers, especially for the smaller ones who cannot have the resources for developing a very rich user interface. So as I said, one of the key factors is that it should require very little hardware. It should be easy to create the user interface because those people who work with hardware usually are not very don't have too much experience with developing for all kinds of platforms with graphical interfaces. And not least, low maintenance is needed, which means that if we have an application that supports our device, we don't want to have to always update it and fixing bugs because that's expensive. So why would one have a separate user interface? Because when software plugins are more common, people are used to more rich interfaces. So they expect that hardware devices would have also something more graphical interface. And this is very expensive to implement because a display is expensive and you need a stronger processor, more memory. So this is not an option for a cheap device or which is produced in thousands. Another one is that those supporting applications need to be available on multiple platforms. So this is already a requirement that if you have a software given with your device, then it has to run on Windows, on Mac. And nowadays, even on mobile devices, it's more and more important to have support for example, tablets. So physical UI on the device is expensive, as I said, adding a high-resolution display. But also sometimes the device itself is so small that it's not feasible, it's not possible to add a graphical user interface. Most manufacturers, therefore, supply some kind of editor already. This is common to edit to deep edit the parameters. So the idea is, as I said already, we should separate the device and the user interface. Now, what are the requirements that I think would be important? Again, it shouldn't require expensive hardware on the target device. Of course, this includes the interface between the UI and the device, which can be anything like USB or some wireless connection. It should have resolution independent graphics, because you don't know what kind of system will be used for running the UI. It would be very good to have a platform-independent text-based layout description, because we really don't want to write C code for all the UI stuff. Basically, we are talking about simple UIs that have some buttons and sliders and text fields, so it's not anything very complicated. But it should have customizable look and feel, because manufacturers want to have a specific style or colors. It should be possible to extend the system with custom controllers or visualizations. So that's a nice thing, because if someone wants to add, for example, envelope parameters, then it may be more intuitive to have a graphical editor for that. It shouldn't include proprietary tools or technology. So it should be free from licensing issues. This is also a requirement of low cost. And it should work on all major platforms, which is really a difficult thing. So what platform can be used to create the system? For the interface between the device and the user interface, I think USB is probably the most common and the cheapest solution. Bluetooth, MIDI over Bluetooth is getting very strong momentum, because Apple supports it on both the iPads and the iOS and OS X, and Google is already supporting it. Microsoft will support it in Windows 10. And this is an ideal interface, because it's cheap in hardware, it's wireless, so especially for tablets or mobile devices. But of course, if the device already has some kind of Ethernet or Wi-Fi, for example, it runs Linux, then it's possible to use that as an interface. As I said, wireless is really preferred for mobile platforms. Now, for implementing this framework, we can use a C++ based framework like JUCE, for example. The common concept of these frameworks is write once and compile everywhere. The problem with that is that you still need to have all the tools and all the capabilities and expertise to compile the code on each platform, and you have to maintain all the different versions and support them. So the idea is that we should let this hard work done by someone else for free. And that's where web technologies come into the picture. Web technologies can be used to write the code once and run everywhere, because web technologies are inherently platform independent. So what makes it possible? Modern web browsers have a wealth of technologies already implemented. That wasn't the case just 5 years ago, but today they have plenty of very interesting technologies. They are capable of providing app-like user experience with interactivity and animation. They provide hardware-accelerated 2D and 3D graphics. They include powerful scripting capabilities with just-in-time compilation. They support bidirectional communication. They are available on all major platforms, including mobile devices. They are based on open standards, which are free and license-free. And they are, and this is the most important, I think, they are constantly being developed, bugs are fixed, they are maintained, they are ported to new OSs, and all of this is free for us. That's the point. Google has a lot of money to hire programmers for us. So what are the enabling technologies that can be used? HTML is the language of the web. It's a hierarchical description language. It's the abbreviation of a hypertext markup language. So one can use, of course, HTML to describe a user interface with widgets, but that's not the easiest way. JSON is a JavaScript object notation, which is a very much simplified form for describing a tree-like object structure. Many systems use JSON for serializing or communicating data. XML is kind of a subset of HTML, or actually HTML is a specific version of XML, but XML is used very often, for example, in JUCE as well. So these could be used for the layout description. The most interesting thing is, I think, CSS3, which is cascading style sheets. These are basically rules that you can define to target specific elements of the web page, like, for example, a knob or a slider or a text element, and you can specify all kinds of styles for it. You can, for example, target all the knobs in a page and set them to some specific color, or you can specify just a single one, and you can define very complex selectors. CSS3 also adds flexible layout, so you don't have to write your resize method, and you don't have to write any code, because everything is done automatically. It can be used to add animation, and all parameters can be animated just with a couple of lines. Then JavaScript can be used, of course, for adding custom components. SVG is a scalable vector graphics format, which is ideal for resolution-independent graphics. And it can be also styled just the same way using CSS like HTML. For the communication, we have WebSockets and also Web MIDI, which allows the browser to access local MIDI devices. This is not yet supported in all browsers. Chrome supports it. Now the question is whether this description should come from the web or from the local device. Certainly, if it comes from the web, it has several advantages. It's easier to update, but it needs online connection. If it's local, then it works offline, but it needs a server running on the hardware device. So the solution may be to cache the UI description in the browser so that it can be used offline, and store presets on the device. Additional benefits of having a web-based implementation is that it's easy to integrate with an online user community, because we already have a web-based environment. It's possible to add in-application purchase, for example, purchasing patches or additional functionality in our device. It doesn't depend on App Store review process. This is also something that could be important for developing for mobile devices. And open source has an advantage that users can improve or maintain our code later if we don't want to support. Now, of course, there are some potential problems with that. Browsers have limited access to the local hardware. Browsers have no right access to the local file system because of security reasons. And working offline, as I said, may be a problem. But all this can be solved somehow. Now I have little time to show some of the examples that I didn't find any project that already implements all of these ideas, but there are some related ones. The first two, Interface and Nexus UI, are more like academic projects where some university guys put together some things. For example, here's Interface.js, so you can see the graphics is not very sophisticated. Nexus UI is really similar. All of these technologies are interesting because they are quite kind of pieces of a puzzle. Everything has some good ideas. Web Audio Controls is written by the guy who wrote the Knobman software you probably know for creating animated knobs. And then the last two, Mod GUI and Toolkit, are commercial products, or at least part of commercial products that are open source. Mod GUI is a simple, or not very simple. It's a foot pedal which can be used to download LV2 plugins. So it runs a full Linux, and it can be used as an effect processor. And finally, Toolkit is also very interesting. It has very good widgets already, like knobs and sliders, and you can see the equalizer graphs. So all these can be put together to make this system. And it's not limited to audio or MIDI. You can use it for any do-it-yourself gadgets, industrial control, home automation, home entertainment, Internet of Things, which is now very popular, or wearable technology. So this project is just starting. So I would like to have, if someone is interested in that, either a manufacturer or wants to contribute to the specification, then please contact me. So that the things that we need to discuss is what interface should be between the device and the browser, define this text-based GUI layout description format, what widgets should be supported. As I said, the original idea that it should be a very limited set of widgets. Then define a protocol for preset management, what platforms should be supported, and of course someone has to write it because it's not yet written. So these are basic ideas. So next steps, find a good name. I think this is the most difficult part. Then we can create an online discussion group for discussing things, a mailing list, Google group, or anything else. Create GitHub project, or even create an MMA MIDI Manufacturers Association working group. I have actually brought up this idea at the MMA mailing list, and there was some interest in it. So this could be a larger project. So I expect to hear from you who is interested, who has ideas, wants to contribute. So please join us.
Do we have any questions or observations? Do you want to talk for a little longer, maybe? I do have one observation, which is that at least one synthesizer manufacturer has kind of cheated by building a web server on their synth. So it now communicates via Ethernet. So you have the kind of pre-compiled advantages of web processing on the computer, yes, but the no limitations of file storage and so on, because the web service itself is happening on the synth.
Yes. Well, actually, this mod device has also, it works the same way. It has an integrated web server.
Okay, is that part of modal synthesizers? Is it related to what they're doing?
Sorry?
Is it related to what modal synthesizers are doing? Because that's the company where I've observed this happening.
And they share the first. So. It's mod devices.
Okay.
Called.
So
it's a
the first 3 letters are a coincidence.
Yeah. So thank you.
Thank you.